All right, so my name is Andrew Williams. I work on Google Chrome as part of the Privacy Sandbox team. So I work on anti-covert tracking and platform hardening features. And today I'm going to talk about one of the experiments we're running to incorporate the navigation initiator site into the HTTP cache key. Let's see. All right. So in this talk, I'm going to give some background that's useful for understanding what we're doing. We'll talk through some of the attacks that we aim to mitigate, talk about our experiment, the timeline, and some logistical details with that, and then leave time for questions. All right, so the first thing is, what is the HTTP cache? So at the highest level, it's a store of, for a given URL request, the corresponding response. And so a basic implementation might just be a dictionary where the URL is the key and the response is the value stored. But it turns out that this can leak information across sites. So sites can use things like timing attacks to learn about the state within other web applications. And so Chrome and other browsers have implemented a partitioned HTTP cache, which means that different sites are kind of segmented in terms of what they share. And so this type of attack where you can leak information is called a cross-site leak. And cross-site leaks using the HTTP cache generally take the form of an attacker makes a cross-site request, and then they time how long it takes for the request to finish or for some indication that it's done. And this response time can reveal whether the cache served the request or whether the request came from the network. And then this indicates whether the data has been loaded previously. And again, this leaks application state. Let's see if I can make this big. Perfect. All right, so here is a slide that describes the cache partitioning scheme that's currently implemented in Chrome. And I should say this is all of Chromium, except cache partitioning is disabled by default. It's behind a disabled by default feature flag. So I think it's also likely enabled for all the other Chromium embedders if they flip the flag. But within the Chromium multiverse, it's not enabled on WebView and things like Chronet. But we say that the cache is triple keyed, which means that the cache partition takes into account the top level site, the frame site, and then the request URL. And then the implementation is slightly more complicated than that because it has a few one-off bits that serve various purposes. So one of the ones to highlight is called the isSubframeDocument resource Boolean. And this is set to true for all subframe navigations. We'll talk about what those are. This mitigates a specific cross-site leak. And we'll see an example of that in later slides. There's also a data upload identifier. I haven't looked at this too much, but my understanding is that it makes it so that form submissions are separate, like different form submissions are partitioned separately. And then there's also a bit, not listed here, that is disabled by default, but aims to partition based on whether requests include credentials or not. So that was implemented a few years ago, but has never been enabled or hasn't been experimented with. So this diagram shows what triple keying looks like. So here, these boxes at the top are pages. The boxes within other boxes are iframes, and you can see at the bottom the cache key that is calculated. And so you can see here the outer a.com box. It would have a top-level site and frame site of a.com, so we would say that its key is just a.com. The evil.com iframe here would have a top-level site of a.com and a frame site of evil.com. And you can see it has a different cache key than the c.com iframe since it has a different frame site. And so one thing to note is that these cache keys, they're used when fetching resources from these contexts. And we'll see later that for navigations, things work a little bit differently. But what is a navigation? So navigation is a request that loads a document to be displayed in a window or a frame. And with respect to who initiates the navigations, there's two types, browser initiated and renderer initiated. So browser initiated navigations are things that result from interacting with the browser UI, and render initiated are things that result from interactions with the loaded document or from site behavior. So these are some examples. So for browser-initiated navigations, these are things like typing a URL into the Omnibox and pressing enter, clicking a bookmark, clicking the back or forward buttons. All of that involves things like BF cache and can be somewhat more complicated. Also interesting, like right-click and open a new tab is a browser-initiated navigation in Chromium. I think on Firefox, this is actually maybe render-initiated, but yeah, these are all browser-initiated navigation examples in Chromium. And so these are render-initiated navigations. We kind of subdivide these into two types, top-level or mainframe navigations, and then subframe navigations. So top-level navigations are things like clicking a link or link prefetching using the as document tag, which I think might not be a standard or part of a web standard, but it's something that Chromium implements. Also things like window.open or setting location.href in JavaScript. These all trigger top-level navigations. And then subframe navigations are similar, except that they load a document into an iframe. So things like when you specify an iframe source, this initiates a subframe navigation. Same for the embed and object elements when the corresponding source URL is a document type, because these can load image types and those wouldn't be considered navigations. Also things like clicking a link in a subframe or navigating from within subframe JavaScript. And everything else is not considered a navigation. So this includes things that the browser does just as part of being a browser, like update checks or things like safe browsing, DNS over HTTPS lookups. Like these are requests, but they're not considered navigations because they don't load a document. And then everything else that the renderer can do is would not be considered a navigation. So like fetch or XML HTTP requests in JavaScript or like loading elements or regular pre-render or prefetch. All right, so looking at like cache key calculations, factoring in navigations. So navigations happen before there's a top-level site or a frame site. So how do we calculate the cache key? And what we do is we take the URL and then we just take the origin and compute a site from that, and that becomes the frame site and the top-level site. And then once the page is loaded, we obviously at that point have a top-level site and a frame site. And you can see here, this page loads a resource. So the partition key is there at the bottom. And one thing to note from this example is the two cache keys here are only different by the URL. So today, resources and navigations, like in a scenario like this, will share a cache partition with respect to everything else other than a URL. And then the last concept I wanted to mention is the concept of an initiator. So initiator, usually it's an origin, and it's the origin of the document that caused a request to be made. And it only makes sense for render-initiated navigations because obviously it's associated with a loaded document or page. So browser-initiated navigations don't have an initiator. And some of the uses of initiator today include things like implementing same-site cookies. So determining whether like same-site strict cookies or same-site lax cookies should be sent. Like same-site strict cookies can only be sent for same-site requests or with same-site top-level navigations. So like same-site strict cookies are not sent with cross-site top-level navigations. And so the initiator is used to make that determination. And then I'm sure most of you are well familiar with the differences between origins and site, but an origin is a scheme, host, and a port. And then a site takes the host and then in some ways kind of strips off the subdomains. It computes the effective top-level domain +1. And so that's the difference between these two. All right, so I want to talk about the attacks that are possible today and what can be mitigated if we try to incorporate the initiator into the cache key. So this is one attack. So say we have a malicious page, evil.com, and it just does a window.open of a site that it wants to see if the user has visited. So here it does a navigation to a.com. So we mentioned that for navigations, the cache key is computed just based on the URL. So this has a cache key of a.com, and then the URL. And so this will hit the cache in the same way that it would if a user had typed a.com into the Omnibox and pressed enter. And so in this way, evil.com can kind of probe and determine whether the user has visited this site before using timing. And so there are some sites that maybe users don't want people to know that they have visited, like say sites that can reveal your political affiliation or like adult websites or things where people might not really be interested in evil.com learning about their prior visits. But there's actually an even more scary attack, which is referred to as a cross-site search. And so what an attacker site can do is here it can initiate a navigation to a page that conditionally loads a resource. So in this case, we have a.com/page with image, and say, for instance, it's a mail application that lets you search, and when a search result is not found, it loads an image. So it has this conditional image loading behavior. Evil.com can initiate a navigation to this site, and then initiate a navigation to the resource that is loaded in like the condition case that it's testing for. So in this case, like the image that is loaded when the email results are not found, or I guess the email search returns no results. So you'll see the cache keys computed on both of these loads are the same, the navigation and the resource load. So then the attacker can use timing to actively infer state from this application. So again, I mentioned an example would be like an email application. It could do complex like searches for whether you have an email from Sundar in your inbox. And then the last attack that I wanted to highlight is a variation of this, but using iframes. And this one is actually mitigated in Chromium today. But the attack involves a malicious iframe, where it can initiate a top-level navigation to a page that conditionally loads a resource. And then the attack is where it initiates a subframe navigation. So it just creates an iframe to the image resource. And then in an unmitigated circumstance, it could use timing. But this is actually the case that the is subframe document resource Boolean that we have. This is the attack that it mitigates. So in this case, that initial navigation, the resource load, would have the is subframe document resource bit as false. And in this case, in the second navigation, it would be set to true, and those would not share a cache partition, and the timing information would not reveal any information. So we would like to experiment with incorporating the initiator into the key so that we can mitigate this vulnerability. And so we've come up with 3 strategies that would mitigate the attack, and then also provide different levels of protection for similar attacks or other types of cross-site leaks. So the most basic is adding another Boolean to the key that is set to true for cross-site mainframe navigations. So when a navigation occurs and based on the initiator, the initiator is cross-site to the URL, then we set this bit, and it just kind of mitigates the specific attack where an attacker is navigating to these things that are typically resources. But going a step beyond that, we can also initiate the full initiator site into the key. So this has the added benefit of preventing malicious sites from inferring state from one another. We'll see kind of what that does later. And then the third approach that we want to experiment with is, so instead of just rolling out this mitigation for top-level navigations, we technically have the is subframe document resource bit that is giving us protection today, but we can replace that by incorporating the initiator site into subframe navigations as well. And this would kind of simplify the code and make top-level navigations and subframe navigations work in the same way. So going back to the attack scenarios, this illustrates how or incorporating the initiator into the key kind of mitigates the attack. So here, evil.com, if it initiates the navigation, the is cross-site navigation bit will either be true, or if we incorporate the whole initiator into the key, it'll just be evil.com. And this won't share a cache partition with previous, for example, Omnibox navigations to a.com. And then attack scenario number 2, again, since evil.com initiates that initial navigation, the key will be different. It'll incorporate the initiator. And so, so we'll see in purple here that the initial load has a different key. The resource load will still have the same key as if we didn't incorporate an initiator, because the initiator for that request would be a.com. But the second navigation to the image would have the initiator, and these would differ in their cache keys, and then the timing information wouldn't leak the state from a.com. And similarly, in the third example, if we replace the is subframe document resource bit with the initiator, it similarly mitigates the attack. So that's really nice. Security is great. What is the trade-off? It comes at less performance because we'll have less cache reuse. So what this means is browser-initiated navigations will no longer share cache partitions with legitimate cross-site render navigations. So some examples of this are, like, say you enter a site into the Omnibox, and then say you click a link on a site to that same page. Instead of sharing a cache partitioning like it will today, those would generate different network requests. There's similar examples here. If you click a link on a site and then right-click and do open a new tab, the first one is a render-initiated navigation where we would set the initiator. The second is a browser-initiated navigation where we wouldn't. So those would both issue requests. And then similarly, if we incorporate the whole initiator site into the key, then that means you have some oddities like if you click a link, like a link to the same site on different top-level sites, the initiator will, or I guess on different frame sites, the initiator will be different. So even though you're clicking the same link, you're clicking it from different frame sites, the initiator will be different, and those will not share a cache partition. So there could be performance trade-offs there. So I mentioned we're experimenting with this. We launched the experiment to 1% of stable Chrome last week, and we plan to run for 6 weeks. The results of the experiment will be posted to BlinkOn, so we have a thread there. And wanted to make sure I save time for questions. Let's see.
So this is trying to kind of incrementally improve. I assume if a site does same site lacks or none, probably the timing of the page could potentially differ and the attack is still viable. Is that correct?
Your question is, how do cookie behaviors factor into the timing?
Yeah, I mean, you're kind of saying, hey, I can infer, based on the timing of the window proxy showing up, and I can post message. I'm not actually sure what artifact is observed on the timing, but I assume other things that influence the length of time the page takes to load would also be observable. So if the site differs based on logged in or not, in terms of the response size, I assume the sort of similar threat is still there. Does that question make sense?
I think so. Yeah, the attack scenarios are definitely kind of hard to wrap your head around. Yeah, I know some of the ones that I'm aware of. So the example here use where an attacker can window.open a page and then either wait for some change to like the handle properties, or another variation of the attack is you can navigate yourself to one of these pages using location.href and then like cancel the navigation either by, I think, like navigating it back to yourself, like resetting it, or to some other means. So yeah, I guess what's observable through timing is probably a complicated like amalgamation of maybe cookie loading and then retrieving from the cache. But I will say I'm definitely not an expert on the attacks and especially the timing side. I've looked at some POCs and they kind of look like black magic JavaScript. Like, what is this even doing?
Can I ask one other? Or? Yeah. Okay. So I guess the other thing is, like, I imagine some sites wouldn't be thrilled about the perf or CDN exhaust costs of less caching. And then we also have things like related website sets that say, hey, these are conceptually similar. Have you considered a CORS-like mechanism where maybe two types of initiators are passed to the networking stack, and depending on how the response comes back, the site could either opt into, yes, I want partitioning in this case, or don't bother, everything's fine, I'm fine with this other origin observing things about me?
Yeah, that's a good question. So we haven't thought of too many technical mitigations like that. I mean, there are things like CoAP and co-op that prevent some of these types of attacks today. The thought is that if we can incorporate the initiator kind of as a default thing, then sites that don't have the resources to implement, the more complex like security protocols, they kind of get this protection for free, and it kind of just improves the security across the web all at once. But it would be interesting to explore if sites could maybe, in a safe way, enable more reuse. Like for instance, you mentioned related website sets. Like maybe that could factor into the key. But yeah, I haven't thought too much about that. Definitely worth considering.
So before I go to the next question, do you have a link to the explainer or the slides somewhere in your slides? Someone was asking in the chat for a link to one of those.
Oh, I think it's in the presentation, or sorry, the conference list. But yeah, I don't know how I can get it from here.
Hey.
I can post it.
Oh, sorry. I was curious on the trade-offs by having these separate caches on Core Web Vitals like First Contentful Paint versus saying having the cache be almost a faux cache, if you will, where we use it as a signal to throttle the timing attack vectors in the calling renderer without shifting the actual loading of the website for the user.
Yeah, so when deciding to run this experiment, we had some conversations about what's the right approach. Should we change the cache key and then take the performance hit, or like you mentioned, should we try to just cut out the timing vectors that exist? And from talking with some of the security experts within Google, it sounds like it would very much be a game of whack-a-mole. And some of the some mitigations have been applied to various techniques that are more consistent today. But the sense that I've gotten from the ISE team at Google, the security experts, is that it would be very challenging, and it also would change over time as the web platform evolves. So if we can take this approach that kind of mitigates the underlying issue, and the performance cost isn't too high, then it'd be a much easier path than trying to fix all the timing sources.
How does the initiator interact with redirects? Is it reevaluated at each hop, or?
That is a good question. So I know for top-level navigations, the frame site and the top-level site, I believe both update with redirects. The initiator field, I'm less familiar with, but my inclination is that it doesn't change, but I'm not 100% sure. Yeah, from a
the initiator should not change across redirects.
Yeah, from my perspective, I'm relatively new to navigations and the web platform, and the initiator field is populated broadly within Chrome, and it was very easy to access. But yeah, that's not an aspect that I'm intimately familiar with. But yeah, thank you.
You explicitly called out a bunch of non-navigation, fetches like fetch. Those are those already mitigated? Like, that doesn't have this complexity of initiating navigation. It's just like, I know the context of the iframe that I'm in, therefore that's part of the cache key.
Yeah, so for everything that's not a navigation, the cache partitioning that we've already implemented, the triple key, prevents the cross-site leaks because it incorporates the top frame side as a privacy boundary and then the frame side as a security boundary. So yeah, for fetch, we solved the problem when we shipped triple keying. It's just navigations is kind of a weird state that we haven't mitigated yet.
Service worker interaction. Should the service worker be aware that, hey, maybe I shouldn't return a response out of the cache API instance I already have, and instead hit the network again?
That's a good question. I have not investigated the service worker interactions. I would think service workers would be partitioned as part of storage partitioning. So maybe as a leak vector there, there's mitigations, but maybe also I don't fully understand the scenario. But yeah, something I should follow up on for sure.
Did this include the prefetch in the non-navigation requests?
So my understanding of prefetch is that
Specifically, the situation rules prefetch, which itself is not navigation, but will be used for serving navigation.
okay. So I didn't look specifically at the speculation rules API.
Yeah.
If the requests within Chromium are constructed such that they resemble navigations generally, then they will be included as navigations, and then the initiator will be incorporated into the cache key considerations. But yeah, I didn't look specifically at it, so I guess it would depend on how the Chromium implementation is. So thank you. I will take a look at that.
This might be a little naive question, but it kind of is similar to like the core's question. So to do these navigations, they have to do a DNS lookup anyway. Would like having a allow list or a safe origins list in the DNS be a viable option, or would that just kind of shift the attack surface?
So the DNS cache is partitioned as part of network state partitioning. Is your question whether the DNS lookup itself contributes to the timing attack?
No, more of would it be a viable way of filtering, like having a list that you can query in the DNS that's like these are allowed to do cross origin lookups, and they can use the cache basically. Because that would happen before the HTTP request, but like, at least I think it would.
Yeah, that seems possible. Although I guess, like, how would the browser decide which origins to allow? Like maybe based on related website sets? Is that what you're thinking, or?
Maybe I can. Okay. Yeah, I think the idea is sort of like how encrypted client flow works, right? You look up some DNS record that has some metadata about how I'm about to connect to the site. So you could imagine some might be a lot of complexity for the use case, but a domain could kind of have some DNS record saying I'm fine with cross origin or these the specific attack vector. I handle it myself sufficiently, or maybe even have an origin list. I don't know if it'd be a Boolean or something more complex, but that's the idea, correct?
Would you mind repeating that?
Yeah. I think the comment was maybe scope to subdomains x.y.com or y.y.com, or I think we're quickly getting into ETLD and same origin and same site type of things. But yeah, I guess the general questions are just around. I know from experience there's sites with like Office that may have different domains, and they won't be particularly thrilled if every time there's an interaction between them, they've got to have a separate cache.
Yeah, thanks for the call out. We did choose to go with the initiator site versus initiator origin to hopefully mitigate some of the concerns for like same entity, at least same site use cases. But yeah, if we do experience performance issues, I think that'll be the point at which we start brainstorming more creative solutions. But for triple keying, when we rolled it out, we didn't see huge negative performance hits, and so we didn't implement any like opt-out mechanisms for triple keying. So if
these sites saw a huge impact from it, it wasn't enough
from
aggregate, but Yeah, sorry. Just the comment was like the Office folks saw huge impacts from triple keying.
Oh, interesting.
But yeah, I think there may be a special case, just how they've set up their domains and typical user interactions.
Yeah, that's good to know. If you have any more insight on the specific cases that were affected and might be affected by this change, definitely let me know. Maybe interesting to consider more.
I'm just curious. So the triple keying includes origins that might be opaque, right? What happens in that case? Like, do any sites hit any degenerate cases because of that? Because like they never reuse the cache, or
So for the HTTP cache, if an opaque origin is in the top level site or the frame site, it's considered transient and then not cached at all. So it's thought that like an opaque origin is probably not going to be reused since they're unique. So the benefits of caching in that point would just be like detrimental. So that probably does eliminate a lot of the edge cases that you might have, but there are other partitioning projects within Chrome that do handle like opaque origins, like storage partitioning, for instance, handles opaque origins the same way that they would any other origin. But yeah, for the HTTP cache, opaque origins cause a node caching to be performed.
All right, I think that's it. Thank you very much.